A catalyst is a particle that can increase the rate of reaction while not actually being consumed by the chemical reaction itself. Catalysts have a couple different ways that they can work. One of the main ways they can work is they can provide an alternate reaction mechanism that allows the reactants to go from being the reactants to being the products without going through their normal high energy activated complex state, but providing an activated complex state which is less unstable and as a result reduces the activation energy. Let's imagine carbon monoxide reacting with oxygen to form CO2. Now, this reaction might have a chemical potential energy diagram like this, chemical energy, where the carbon monoxide is at some energy level, and then it has to go way up to some really unstable activated complex, and then it can come down and form the more stable CO2. This activation energy, this is our activated complex. And this activation energy being large makes it unlikely that when a carbon monoxide and oxygen molecule collide, that they would be able to have enough energy for that collision to be successful. So while carbon monoxide and oxygen might collide all the time, very few of those collisions will result in an actual chemical reaction. Now, if we imagine putting a palladium surface in the area, what that does is it allows the carbon monoxide to come and sit on the palladium surface. And it actually allows the O2 molecule to separate into individual oxygen molecules sitting on that surface. Sitting on the surface, all of these things breaking apart an oxygen into just into a single oxygen would have been extremely high energy. But sitting on the palladium surface, it's not quite as unstable as it otherwise would have been. What that allows then is that for these particles to find each other and form CO2 without oxygen ever having to have broken up and formed just two O's hanging out in the air. This is very unstable. This is still unstable, but it's less unstable. So if I imagine the chemical energy diagram for this reaction with the existence of palladium there, then I start at some and I'm going to end at the same spot. But because this reaction can take part in a number of more stable states, I'm not going to go up like I did here to this very unstable state. Instead, I'm going to go through maybe a bunch of smaller stages and then come down to that same change. The overall change in energy here would be the exact same, but we never had to go to that high energy activated complex state. The palladium here provided a surface for this to happen without going to there. What that means then is that when collisions occur, they don't have to have this huge activation energy. They can have these smaller activation energies, which means it's more likely that the average collision will be successful in completing this chemical reaction. If we imagine our Maxwell-Boltzmann distribution, and we have our curve like this, and this high activation energy, I'll call it A, may be sat out here. And so we would say at most, say 5% of those collisions could lead to chemical reactions. Moving down here to these smaller activation energies, I'll call this B. Here we can see that we can reduce it all the way down here, and maybe we're getting like 40% of our collisions which can result in a chemical reaction. That's an increase in 8 times, which means the reaction rate is going to go 8 times faster, having avoided that unstable state. Catalysts don't always work to provide these more stable intermediate states. In some chemical reactions, catalysts can also work by simply bringing the reactants together. If a reaction requires 3 or more particles to try and be in the same location at the same time for the chemical reaction to occur, a catalyst could be used to attract all of those reactants to the same location and increase the likelihood of a collision in the first place. So they can reduce activation energies, making more of the collision successful, or they might serve as a reaction site where they can make the collisions more likely in the first place. Either way, they don't get used up in the reaction because after the CO2 forms, it leaves the surface's palladium and leaves that palladium alone. So they're not used up in the reaction, they simply allow it to go faster.